And now let's go over a concept example. So to give a real life analogy, let's imagine a company's hiring process. Now, mind you, for every single neural network that we have, we always know that a neural network has three components. We have an input, one or more hidden layers, and then finally the output. Let me just do that. And training of the neural network. Work and focusing on one specific neuron is that one neuron is always going to be equal to the activation function times the sum of all of the following weights of the inputs and the input value plus the bias to the power of the number of the inputs of the neuron for each component. And when training, we have weights, biases to consider, and an activation function. It's highlighted in the neuron formula here. And we wrap that all up with an optimization algorithm. There'll be more further in-depth videos talking about the training of a neural network. But right now, this is just an overhead overview and just to be able to understand the structure of neural networks. And so when we are imagining a neural network with an HR team, we are going to be imagining that that the neurons are going to be the HR team, the layers, one or more hidden layers, are going to represent the stages of the hiring process. And the activation functions are refers to the decision criteria. And the output determines if the person is hired or not. So it's a hiring decision. Hired yes or no. Or just ask ourselves, should we hire this person? Initially, resumes are screened based on the experiences and skills, and this is the input layer. So input layer, initial screening. Next, the selected candidates undergo several rounds of interviews. These are the hidden layers. Stages of the hiring process and interview rounds. And where we understand more about the evaluation that occurs. Finally, the hiring decision is made, as we have said, from the output layer. So that's where the magic happens. And at each stage, certain criteria must be met for a candidate to proceed, like the activation function determines if a neuron signal should pass to the next layer. All right, so, and activation function. Determines if a neuron should proceed to the next layer. And then going into our further concept understanding. So the steps for us to be able to actually put out inside of our model is that one, we already initialized the following libraries. It looks like we're going to be importing a sequential model as well as a dense model as well from the Keras libraries and well, the dense layers really from the Keras layers part and the Keras models that are also available. So we're employing a sequential model along with dense layers for our following model that we're applying. So after we have imported, we're going to assume that X is the input database with multiple features and Y is the output of the labels. For every instance of X, could be a matrix of the application of resumes with features such as the years of experience, skills, range, etc. And Y could be binary labels indicating whether the applicant was hired, 1, or not, 0, based on the criteria. So initially, we would load our data. Then we declare our model, and this is where the hidden layers and all the layers go through. It looks like, so initially the sequential model we have right here, we initialize it and allows us to build a model layer by layer. And this is where we add the input layer, which corresponds to screening resumes on experience and skills, such as we have 10 features we look at, hence 10 input neurons. This is our input layer that we have. Then the hidden layers go. So we have layers, and then this part hidden. So adding a hidden layer, which is akin to the first round of interviews in the hiring process, we use 15 neurons, arbitrarily chosen for the purpose of this example, and the ReLU activation function, which we already went over in our activation function section / video. If needed, we can add more hidden layers, each representing subsequent rounds of interviews. So for this example, we'll add one more hidden layer. So we have a second hidden layer, one hidden layer, and adding the output layer representing the final hiring decision. We use one neuron since the outcome is binary, hired or not hired, and the sigmoid activation function. Sigmoid activation function, and we use one neuron since the outcome is binary. And we compile the model with a binary cross-entropy loss function. Let me just actually fix this over here because technically, so all these parts are going to be layers. Let me clean this part up. So this is our input layer. And then that part is hidden layer. Then we compile, and it looks like we're using the Atom optimizer as a good default choice for general purposes, and it's great for binary classification. And we summarize the model structure, which helps us provide the visual neural network layers and neurons. And at this point, we would train our model with application data, not shown in this example, since we don't have that much data, and this is just a given example that we have. So we have a batch size of 32 with 100 epochs as well. After training, we could evaluate our model's performance, akin to reviewing the hiring process effectiveness, and then we make our predictions for new applicant data, such as once we put it in and already trained the model accordingly, just based on the Keras library that has already been expansive, we can put in new data to be able to put inside of our following model that we have already put. So it's calling upon the model to predict based on the data. It's going to run the sequential model through the input layer, hidden layers, compile and have the loss function as well to summarize. And then and this is the training part. To fit our batch size data. Let me just zoom out and clean up for you folks. And actually, if you want to take a screenshot of this part, by all means do so. And just move it out right now. Let me see if I can make this bigger. Okay. Yep, so there we go. Let me just clean this part up. There we go. And now let's head over to our second concept example. And so yeah, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.